can see the theory parts of one-way classification. So, if we get a problem, first we assume the null hypothesis. First step is we assume the null hypothesis. I already said that null hypothesis is the in the study of mean means means are equal. Otherwise, in the study of variance means variance are equal. So here we can take our null hypothesis is means are equal. Mu1 is a first population mean, mu2 is another population mean, etc. mu3, etc. mun. Mu k. I take a k samples mean. We can say k samples mean. First sample mean is mu1. Second sample mean is mu2. Third sample mean is mu3. So, etc. mu k be the kth sample. So, I fix some k. K can be 10 or 11 or 5 or 6. So, 5 means mu1, mu2, mu1 equal to mu2 equal to mu3 equal to mu4 equal to mu5. So, I generally say that k samples. So, our null hypothesis is mu1 equal to mu2 equal to mu3 equal to etc. mu k. Okay, this is the first step in the one-way classification. We assume null hypothesis. Next step is we calculate t value. T is sum of all observations in row and column. That means we have two population P1, P2. So here observation. So here we have a total. Here also we have a total. This is the column total. Here we have a total. Here we have a total. So then we can, this is the row total, each row total, and this is the each column total. So this total and this total is here. We can write here. That is the T. Okay. This total is T. First, next calculate the value of T. Next, SST. How to calculate SST? SST is sum of all observations minus t square by n. Sum of all observations minus t square by n. I will write some SST equal to sum of all observations minus sum of square of all observation. Sorry. Sum of square of all observations minus t square by n. This is the SST. Next you calculate SST. SST is sum of square of all observations minus t square by n. What is the sum of square of all observations? We have observations. So P1, P2. P1 is x1, x2, etc. etc. Some x3, x4, and here y1, y2, y3, y4. And x5, x6, x7, x8. I will say x. So x5, x6, x7, x8. So sum of square of all observations. So you take this observation square. You take this observation square. Next you take this observation square, so x1 square, x2 square, x3 square, x4 square, x5 square, x6 square, x8, x7 square, x8 square. This is the sum of square of all observations, means each observation's square. You take each observation's square and add it. That means x1, x2, x3, x4, x1 square, x2 square, x3 square, x4 square, x5, x6, all squares, and both of them add it. That is the meaning of sum of square of all observation. Minus, you already take the value of t. T is total sum of column and row. T square by n. What is n? N is number of columns into number of rows. That is n. Clear? SST. How to find SST? SST is sum of square of all observation minus t square by n. Sum of square of all observations means you take each observations and square it and add it. Okay? Then that is minus t square by n. That is the third step. Next is you find SSC. What is how to find SSC? SSC means sum x1 square by n1 plus sum x2 square by n2 etc. minus t square by n. SSC is sigma x1 square by n1, sigma x2 square by n2. That means you have some observations. So we can first column we say x1, next column we say x2. So you take 4 samples. So we have 4 columns, x1, x2, x3, x4. So sigma x1 means this column sum. Sigma x2 means this column sum. Sigma x3 means this column sum. Sigma x4 means 4th column sum. That is the meaning of sigma x1, sigma x2, sigma x3, sigma x4. First we say, this is the 4th step. We will say 3rd step. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We take the numbers. So easily you can understand. So how to find SST? SST means each of the observations square. So 1 square plus 2 square plus 3 square plus next 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus 8 square. That is the meaning of sum of all observation. This is the, now I will explain 3rd step. SST, how to find SST. So each of the square, you take each of the observation square, 1 square, 2 square, 3 square, 3 square, 4 square, 5 square plus 6 square, 7 square, 8 square plus all squares you take and add it. Then minus t square by n. Here you take first column sum, second column sum, third column sum, fourth column sum. So here 3 plus 3, 6 sum. Here 12. Here 21. Here 30. And sigma x1 square. That means 6 square. Here 6. So 6 square plus 12 square. So divided by n1 means how many observations? N1 means 1, 2, 3 observation. So 6 by 3. 6 square by 3 plus 12 square by 3 plus etc. This is the finding, how to finding SSC. SSC is each column, first you take each column sum and square divided by each of the columns. So x1, x2, x3, x4. You take x1, x2, x3, x4, 4 samples. So first you find each of the column sum. So you got a sigma x1, sigma x2, sigma x3, sigma x4. Next you square it. Sigma x1 square, x1 square, sigma x2 square, sigma x3 square, sigma x4 square. And you take sigma x1 square divided by n1. n1 is number of observations in that column. So here 3 observations. So sigma x1 square divided by 3. Next sigma x2 square divided by number of observations. It also here 3. So you can write sigma x2 square divided by 3. Similarly you can proceed. So this is the fourth step. First you find a t value. Next you find a SST value. Next you find a SSC. Next SSE. SSE equal to SSC minus SST minus SSC. SSE means you already find out SST. Next you find SSC. SST minus SSC is the SSE. So you got SSC, SST and SSE. Next you can find M. Mean MSC. MSC is SSC divided by K minus 1. MSC equal to SSC minus K minus 1, where K is the number of columns. Number of columns. So how to find MSC? MSC is the SSC divided by K minus 1. Okay. Next MSE. How to find MSE? MSE is the SSE. Here MSC. So SSC. MSE. SSE divided by N minus K. N is the column total into row total minus K is the number of samples. Next you can calculate F ratio. What is F ratio? F ratio is the MSC by MSE. So you calculate MSC divided by MSE. So you got calculated F value. Next you can find table value. F table value. F table value, here you need degree of freedom. Degree of freedom is K minus 1 comma N minus K. K minus 1 and N minus K. K minus 1 N minus K is the degree of freedom. Degree of freedom, and you can take level of significance is in the problem. Give any level of significance, you can take that level of significance. Otherwise, you can take 5% level of significance. Then you can calculate this degree of freedom corresponding to 5% level of significance or other level of significance. You got F tabled value. Tabled value of F. Next, tabled value, calculated value, calculated F value less than table F value. Then you can conclude. Our hypothesis. What is the null hypothesis? Null hypothesis accepted. Calculated F value less than tabled value, we can conclude hypothesis H naught accepted. Otherwise, H naught rejected. H naught accepted means all of the samples have same mean. That is, all of the samples. H naught accepted means all of the samples have same mean. Otherwise, all of the samples have different means. Okay. This is the procedure of one-way classification of data or one-way ANOVA, one-way analysis of variance. Here, ANOVA, one-way ANOVA table have a source of variation, sum of squares, degree of freedom, and a mean square. This is the criteria. And you take a between sample and a within sample. Next, total. So, SSC is the sum of between samples and SSE is the sum of within samples and SST is the total. Next, K minus 1 is the degree of freedom of between sample. N minus K is the degree of freedom of within sample. N minus 1 is the degree of freedom of total. Next, you can find corresponding mean values MSC and MSE. This is the ANOVA table. So, I already explained how to find SSC. SSC is the sum of square between samples. SSE is the sum of square within samples. SST is the sum of square of total. Next, K minus 1 is the degree of freedom of between sample. Degree of freedom of within a sample is N minus K. Degree of freedom of total is N minus 1. Next, you can find MSC and MSE. I already say how to find MSC and MSE. This is the ANOVA table. ANOVA table presents the obtained results in the classification of data. Okay, that is the ANOVA table.